In early 2026, a quiet crisis began to unfold. It did not start with a bang or a crash. It started with a purchase order. Companies began ordering a new generation of artificial intelligence hardware. This hardware was powerful. It promised to unlock new frontiers in AI development. But it came with an immense and unforeseen cost. The demand for electricity from these new systems was staggering. Power grids, already under strain, began to show signs of stress. Utility operators raised quiet alarms. Data center managers scrambled for solutions. People in the tech and energy sectors started calling it the Blackwell power crisis, named after the new chip architecture driving the demand. The source of the power crisis has a specific name. It is the GB300 NVL72. This is not a single chip, but a massive integrated system. A full server rack packed with NVIDIA's latest processors. These racks are the engines of large-scale AI. They perform trillions of calculations to train and run advanced models, but that performance comes at a steep energy price. Each GB300 NVL72 rack draws about 120 kilowatts, 150 kilowatts. By comparison, an average American home uses about 1 to 2 kilowatts, so one rack consumes the power of roughly 100 homes. A data center can contain hundreds or thousands of these racks. It's called rack density, computing power and electricity consumption per rack. For decades, the goal was to increase density, more power in less space. But the GB300 NVL72 pushed density to an extreme. A 150 kilowatt rack generates immense heat. Traditional cooling, blowing cold air, became ineffective. Air couldn't carry away heat fast enough. Chips overheated and failed in minutes. The industry had to find a new solution: the liquid cooling transition. It wasn't just about delivering power. It was about managing the consequences: heat. Liquids bring cooling directly to the hottest components, absorbing and transporting heat thousands of times more effectively than air. Liquid-cooled data centers look more like processing plants: pumps, exchangers, cooling towers, leak detection, massive construction, high stakes. On Friday, February 27, 2026, the AI world was shaken by a major announcement. OpenAI secured $110 billion, the largest private technology funding round in history. Led by Amazon, NVIDIA, and SoftBank, it signaled that AI isn't just a feature, it's the future of tech. This created a powerful feedback loop. OpenAI needs chips and electricity. NVIDIA makes the chips. Amazon provides the data centers and power. Money flows to OpenAI and back to Amazon and NVIDIA. The financial boom in AI translated directly into a demand for megawatts, fueling the Blackwell power crisis. OpenAI expanded its AWS partnership, an additional $100 billion over 8 years, extending an existing $38 billion agreement. To meet it, Amazon must build and operate more data centers, fill them with NVIDIA chips, and, most importantly, secure enormous amounts of electricity. Money becomes a tool to command resources, including large portions of the nation's energy supply. Amazon signs long-term power deals, then funds new plants, shifting from buying power to controlling it, even building behind-the-meter supply. It ensures reliability for AI and nudges a public resource toward private stewardship. The GB300 NVL72 didn't just advance AI, it redefined what a data center is and who controls the power behind it. The liquid cooling transition made extreme rack density feasible and amplified grid stress beyond the data hall. As capital surges into compute, it surges into electricity. The line between cloud and grid is blurring by design. One option rose to the top of the list: nuclear power. The term nuclear AI entered the discourse. AI data centers need vast, stable, always-on electricity. For some, nuclear offered the perfect solution: carbon-free and continuous. Amazon partnered with Energy Northwest, a public power consortium in Washington. The plan? Acquire a data center campus adjacent to a nuclear plant and help develop up to 12 small modular reactors. SMRs are smaller, factory-built, designed for safety and flexibility. Google announced a partnership with Kairos Power. Kairos is developing an advanced molten salt-cooled reactor, promising enhanced safety and efficiency. Not yet a full plant commitment, but a clear signal. Next-gen nuclear is on the table. These deals aren't just about buying power. They're about shaping energy technology to fit AI's needs. The economics changed. Efficient chips justify reliable, dedicated power. If you own the most efficient chips and cannot buy the power, you build it. Linking AI infrastructure to energy infrastructure. Nuclear AI marks a profound shift. Private tech capital underwriting the next era of baseload power. The spectacle of big tech consuming city-sized electricity caused alarm. If these companies absorb new capacity, what happens to everyone else's electric bills? The concern reached the highest levels. The White House moved to secure a commitment. The White House Ratepayer Protection Pledge. A formal signing ceremony, March 4th. 7 of the largest, most power-hungry companies were set to sign: Microsoft, Google, Amazon, Meta, XAI, and others. Under the pledge, companies would build, bring, or buy their own new power supply for AI data centers, protecting ratepayers. It formalized a two-tiered energy system: public grid for homes and businesses, private parallel grids for big tech. It could shield households short-term and accelerate tech's control over energy assets. A green light to build portfolios: natural gas, nuclear, solar, wind, often outside traditional regulatory structures. The long-term consequences for oversight and markets are profound and still unfolding. The pledge accelerated a trend already underway: behind-the-meter power generation. Anything on the user's side of the meter is behind the meter. For data centers, that means on-site or nearby plants that directly serve the load. They're no longer just customers, they're their own utilities. By 2026, behind-the-meter projects reached 56 gigawatts across 46 U.S. sites, a private power boom rivaling the public grid. Reliability drives the mix. Natural gas leads early, fast start, steady on-demand electricity when wind or sun falter. Hyperscalers are now energy producers, choosing tech, fuel, and locations to serve AI uptime. Many choices shift from public forums to corporate boards, raising community and environmental questions. The events of 2026 revealed a new equation. Power and computation are two sides of the same coin. The company that controls the most efficient chips has an edge, if it can secure the energy to run them at scale. As one analyst noted, if you own the most energy-efficient chip, you effectively own the energy market. Money buys chips and cloud. Cloud builds data centers and power, capital and resources loop, concentrating control. When few private actors control compute and energy, they gain outsized influence over prices, access, and innovation. Laws built for railroads and oil may not fit a world where one platform can own the cloud, the plants, and a stake in the models. The vertical integration of chips, data, and power is a new kind of consolidation: fast, quiet, and vast. Understanding this new equation is the first step to ensuring AI's benefits are broadly shared, and its power responsibly governed. The story of big tech and the grid is still being written. New AI systems like the GB300 NVL72 created unprecedented demand and forced a liquid cooling transition. Massive capital is fueling a race to build infrastructure, compute, and power. That race led to nuclear AI and a boom in private, behind-the-meter generation. Opportunity: accelerate cleaner, reliable sources, advanced nuclear, geothermal, smarter efficiency. Risk: a privatized parallel system that weakens the public grid, raises costs for those left, and reduces accountability. What's needed now is steady, deliberate action. Build new oversight for a hybrid energy system. Enforce safety and environmental standards. Protect grid stability and affordability. Transparency is paramount. Deals must face public scrutiny. Communities must have a voice. The Ratepayer Protection Pledge is a start, not a substitute for durable rules. The promise of AI is immense, but not at the expense of a fair, reliable energy system. Citizens must demand clarity from leaders and accountability from companies. The future of AI is being built on the electric grid. That foundation must remain strong, stable, and subject to the public will. The AI power grab is here. The question isn't whether big tech can buy the grid, it's how we ensure the grid still serves everyone. And global markets. Night. The AI power crisis is reshaping markets. Here are 3 stocks to watch as compute collides with the grid. INT. Trading floor. Night NVIDIA. Ticker. NVDA. The chipmaker at the center of AI demand. Blackwell-class systems drive unprecedented compute and electricity needs. INT. Data center. Night NVIDIA's edge performance leadership. NVIDIA's software ecosystem. NVIDIA's supply chain partnerships. If AI training expands, demand for their accelerators and supporting power grows in lockstep. INT. Market ticker wall. Night risks. Cycles in data center capex. Supply constraints competition. Opportunity. Scale economics recurring platform lock-in. INT. Cooling plant. Night Vertiv. Ticker VRT. The infrastructure enabler. As rack density soars. Liquid cooling power distribution. Thermal management, INT. Control room. Night Vertiv's play. Converting data halls to high-density, liquid-cooled layouts, pumps, manifolds, heat exchangers, controls sold as systems and services. INT. Chart room. Night risks. Execution scaling project timing. Opportunity. Retrofit wave standardization of liquid cooling across hyperscalers. EXT. Energy complex. Dusk, Oklo Inc. Ticker OKLO. A nuclear innovator. Small factory-built reactors steady behind-the-meter power for AI campuses. INT. Reactor simulation. Night Oklo's thesis. Reliable base load near data centers. Early-stage regulatory milestones. Project delivery milestones. INT. Market overlay. Night risks. Licensing, financing, construction timelines. Opportunity. Long-duration power contracts aligned with AI uptime. EXT. City grid. Night 3 different roles in one story. Chips cooling power. Not financial advice. For research only.